Hello everyone, welcome to part 2 or day 2 of our 13.1 lesson. Today we are talking about how to simplify expressions using trig identities. So it would be handy to have your maybe table or chart of identities because we'll be looking back at those pretty frequently today. But otherwise we're going to talk about what does it mean to simplify an expression that involves these identities. So let's do that first. Okay, so first of all, let's look at this. Simplifying the expression when we're looking at something like what we have over on the left. That's going to mean we want our final answer to either be just one trig function, so for example, cosine of theta, or we want a single value. Oftentimes we'll be able to simplify all the way down to just 1 or sometimes even just 0. So that's something to look out for. So just a single trig function or a single value. Once we're down to that, we know that we are done. Okay, let's look at our first example where we are given sine of theta times cosecant of theta minus sine of theta. Or if we take out all those extra of thetas, of course, sine times cosecant minus sine. Okay, how do we manipulate this thing? Well, the first thing I'm seeing that we could do is to distribute our outside sign. We could multiply that through our parentheses. If we do that, let's take a look at what we actually get. We'll get sine times cosecant minus sine times sine. Okay, well our sine times sine, that's going to be the same thing as sine squared of theta. So that's going to be how we want to write sine times sine, or really any trig function times itself. We'll want to just say that's the thing squared. Okay, what about that first term though, sine times cosecant? Well, remember that cosecant is one of our reciprocal functions. We also have a reciprocal identity involving cosecant that tells us cosecant is equal to 1 over sine. So I could rewrite this expression then as sine times 1 over sine minus sine squared. Okay, well sine times 1 over sine, let's simplify that. That's actually the same thing as sine over sine. And then we're not really changing our minus sine squared piece. Well, sine over sine, that's like x over x, 4 over 4. Anything over itself simplifies simply down to 1. So what we really have is 1 minus sine squared of theta. Now this isn't fully simplified. Again, we want just one trig function or a single value. We have kind of both going on right now. However, I'm going to take a moment to remind you of one of our other trig identities. That this is our sort of initial Pythagorean identity that says cosine squared plus sine squared is equal to 1. Now our so far simplified expression involves a 1 and a sine squared. I'm going to actually manipulate our Pythagorean identity here and see if we can get something that looks like 1 minus sine squared. So in particular, let's maybe subtract sine squared from both sides of this expression. On the left, we'll have just cosine squared left over, and then on the right we have 1 minus sine squared. That is exactly what we have in our simplified expression so far, 1 minus sine squared. We just said, just through one step of manipulation, that that is equal to cosine squared. So therefore, I can say, well, this expression, 1 minus sine squared, that's actually going to simplify even further down to simply cosine squared. That is one trig function, so we would say this is our simplified answer. We will often be looking for opportunities to manipulate, especially the Pythagorean identities. So keep an eye out for that. Oftentimes you'll get a 1 and maybe one of the other functions, and that should sort of be a clue to you that, ooh, maybe I need to look back at some of my Pythagorean identities and play with them a little bit. Okay, let's look at a few more examples. That's what this whole video is going to be, is just looking through a few more examples. Okay, number 2, tangent times cotangent. Okay, tangent times cotangent. Well, cotangent, that's involved in another of our reciprocal identities. We have an identity saying cotangent is equal to 1 over tangent. This was basically a step we did in the previous example. Let's rewrite this as tangent times 1 over tangent, which really is just tangent over tangent. You might even be able to skip this little step. Just jump all the way down to tangent over tangent. Well, again, like sine over sine simplified in the previous example, tangent over tangent will simplify all the way down to plain old 1. So this is an example of being able to simplify all the way down to just a single value, not even a trig function anymore. Tangent times cotangent will always be equal to 1. Okay, let's look at number 3. This time we have sine times cosecant all over cotangent. So I'm going to make a couple notes to myself. First of all, that cosecant, like we said before, that is equal to 1 over sine. And just like we said in the previous example, cotangent is equal to 1 over tangent. So maybe a couple ways to show this next step. I'm going to rewrite my expression as sine times 1 over sine all over 1 over tangent. So it might feel like for a second that, ooh, we've just made this more complicated and we're supposed to be simplifying. We've all of a sudden made this into a complex fraction. But I think this will turn out to be a little bit easier to deal with. So sine times 1 over sine, just as we did before, we'll rewrite that as sine over sine. And I'm still going to write that this is over 1 over tangent, so I'm still writing this as a complex fraction. And maybe I should label my steps, like this is step 1, this is step 2. Okay, my next step, let's simplify that numerator. Sine over sine, again, that's just 1. So really we have 1 over tangent. Okay, so if we take this the next step, how do we simplify complex fractions? Well, usually what we do is we take that denominator, rather than dividing the numerator by that, we will multiply the numerator by the reciprocal of that denominator. So we're going to multiply 1 by tangent, and I don't really need that bracket, by tangent over 1. Well, 1 times tangent over 1, that just simplifies all the way down to plain old tangent. And that is our answer, plain old tangent. Okay, I've got a couple more examples for us. Let's dive in. These ones get a little bit more complicated because you can see all of a sudden there are squared things involved. So let's maybe make some notes about how we can rewrite these various things, starting with number 4. So I'm going to take my tangent squared of theta, and just remind myself that we have our quotient identity saying tangent is equal to sine over cosine. We can add in squareds there. Tangent squared, I think we talked about this in the last video as well, is also going to be equal to sine squared over cosine squared. So I'm going to be rewriting tangent squared as sine squared over cosine squared. Let's also think about how we might rewrite cosecant squared. Our cosecant squared, of course, that's one of our reciprocal identities. Just like cosecant is equal to 1 over sine, cosecant squared, I'm just going to throw in my squared there, will be equal to 1 over sine squared. It's really 1 squared over sine squared, but of course 1 squared is still just 1. So we don't necessarily bother writing that extra 1 squared. Same idea for secant squared. That's another reciprocal identity. And we're going to rewrite that as 1 over cosine squared. Okay, so let's put that all together as one expression here. So we're going to have our, like I said, sine squared all over cosine squared times, maybe I'll put all of this in parentheses for now, times, what did we say cosecant squared is? 1 over sine squared. Okay, we're subtracting 1. We don't want to lose that little minus 1 that's in the denominator, or excuse me, in the numerator. Okay, but this is all over, let's see, what is it all over? Secant squared, or 1 over cosine squared. Okay, let's see if we can simplify this. So one thing I'm noticing about our numerator is that there is something that we can cross cancel. So we're thinking maybe back to some of our problem solving steps that we were able to take back when we looked at rational expressions. Notice we've got a sine squared in our numerator, and then down here a sine squared in this denominator. Those terms are being multiplied together, so we can cross cancel those sine squareds. What that means is my numerator, therefore, can become 1 over cosine squared minus 1. And we haven't really done much to change our denominator here. It's still just 1 over cosine squared. Okay, 1 over cosine squared. Let's take a pause and think about that 1 over cosine squared. How can I perhaps rewrite that thing? Well, this is another element of our reciprocal identities. 1 over cosine squared is also equal to secant squared. I'm just going to draw that off to the side. So that means I could rewrite this whole expression as secant squared minus 1 all over, oops, and I'm kind of out of space, 1 over cosine squared. We'll sort of squeeze it in there. Okay, let's see, secant squared minus 1. Check your Pythagorean identities. Is this equal to anything? Hopefully you're looking at that list and seeing, ah yes, it is equal, in fact, to tangent squared. Tangent squared. So we get to even simplify this further. I'm going to draw a little arrow showing we're going all the way up here. Okay, so secant squared minus 1, instead of writing that, we'll write tangent squared. And this is still all over 1 over cosine squared. Like I said, it has gotten a little bit more complicated, right? Now, let's see. I think I do want to go ahead and get rid of this complex fraction. I want to multiply tangent squared by the reciprocal of my denominator there. But at the same time, I'm going to take the step of turning tangent squared, like we did before, into sine squared over cosine squared. Remember, we did that kind of in our first step as well. So that means I'm going to have tangent squared, but actually I'm going to write that as sine squared over cosine squared. And rather than saying that's over 1 over cosine squared, I'm saying that's multiplied by the reciprocal. Cosine squared, oops, forgot my little s there, cosine squared over 1. And a very nice thing is happening again for us here. We do get to, again, cross cancel our cosine squareds, which means we are finally left with plain old sine squared over 1, or of course, just sine squared. That would be our fully simplified version of the original expression. So, yeah, certainly more complicated than the previous examples. Let's do just one more. This one again is going to involve our reciprocal identities, or excuse me, just involve our squared is what I meant to say there. Of course, it could involve any of those identities. I do want to focus maybe first on this 1 minus cosine squared. Again, I want us to go back to our cosine squared plus sine squared is equal to 1. That's our first Pythagorean identity. If I subtract, I forgot my little theta there, if I subtract cosine squared from both sides, then what I'm left with is sine squared is equal to 1 minus cosine squared. So again, another opportunity here to manipulate our Pythagorean identity just a little bit and say, oh, 1 minus cosine squared, that's going to be equal to sine squared. So that's the first main step I want to take. Let's rewrite our expression there. Secant over sine times sine squared. Okay, well, sine squared, maybe I want to rewrite that out as, in fact, maybe I'll take this step now. I'm going to write it as sine squared over 1. Okay, and maybe it would be helpful to actually rewrite that as secant over sine times sine times sine. Sine squared is really just sine times sine all over 1. And the only purpose that is kind of helpful is because we can see that we can cross cancel some elements. Our sine here and one of our sines in the numerator can cancel out. So that means I am just left with secant, let's stick with our green here, secant times sine. No longer sine squared, just plain old sine. We could write that as over 1. If that's helpful to you, then go for it. Okay, so let's maybe remember, of course, that secant is one of those reciprocal identities. It's equal to 1 over cosine. I'm going to write that out. 1 over cosine. I'm just going to leave sine as itself. Maybe I'll write it as over 1. So we have 1 over cosine times sine over 1. If we were to combine that, let's say we're going up here, then we'll have sine over cosine. How do we simplify that then? Well, that's our first quotient identity right there. That is equal to tangent, and that would be our answer. So this got a little hectic. I'm looking back at my work like, wow, this went all over the place. I prefer to work like completely vertically if I have the space, and I'd recommend you try to do that probably as well to keep yourself as organized as possible. But hopefully through these 5 examples, you got a sense of some of the maybe technique to simplifying using our trig identities. Okay, have fun.